the previous videos, we talked about the process of designing the thickness of the pavement layers. This is related to the structural design of the flexible pavement as given in the Arahant technique. We mentioned that there is another category related to the checking of the traffic capacity, utilizing the pavement that you have designed. We're going to discuss in details regarding this. You may refer to clause 3.37 of Arahant technique for the relevant equations. It is stated that the total traffic volume at the end of the design period shall be checked to ensure the maximum capacity of the traffic has not been exceeded. Remember that the design period is 10 years, taking into considerations of the construction period. Now, a pavement is supposed to be designed to be in good conditions throughout that 10 years of design period without requiring any strengthening of the pavement. This is the ideal conditions. That's why you need to calculate the ESA, get the CBR, and then design the thickness accordingly. Another important criteria that you have to check, it will be the total traffic volume. Not only ensuring the structural stability, the design route shall also be ensured in terms of the functionality, where the maximum traffic capacity shall not be exceeded. This slide summarizes the checking process for the traffic capacity. Vx refers to the total daily one-way traffic flow. This can be calculated by using these equations as given in clause 3.3.7. Now, this Vx here is different from the Vc that we calculated previously. The equations differ slightly. Vc refers to the commercial vehicles only, whereas Vs refers to both non-commercial and commercial vehicles. Also, Vc is calculated on basis of total numbers of commercial vehicles in 1 year, as it is calculated on the basis of ADT, average daily traffic, multiplied with 365. That is a total of 365 days in a year. As for Vs here, we are talking about the daily one-way traffic flow. In another word, we calculate the Vc, which is on basis of the commercial vehicles, in order to get the ESA. Based on the ESA, we determine the equivalent thickness from the thickness design monograph. Now we use Vx, which is total daily one-way traffic flow, to check the traffic capacity. The Arahant technique does not provide explanations how to get the initial daily traffic in one direction, but you know the concept. The Vx is referring to the daily traffic flow for non-commercial and commercial vehicles at the end of the design period, whereas V1 represents the one-way traffic flow for both non-commercial and commercial vehicles at the initial stage of the design period. Having this understood, you have an idea how to compute this V1, which is the initial daily traffic. You can get it from the average daily traffic, ADT, which also representing the daily traffic. However, the ADT calculated is in the mode of both directions, assuming equal traffic in both directions. Now the initial daily traffic, it will be half of the ADT as acquired from the traffic survey. Now if you use the traffic survey data, you might need to consider the construction's durations. Let's say your traffic survey is done before the construction. You will need to factor in the construction's durations, taking into account the annual growth over the period of the constructions, so that you will have your V1 here, the initial daily traffic, representing the traffic conditions at the early stage of the design period. The R here represent the annual growth, and the X here represent the design period. For a 10-year design period, the X shall be equals to 10. Now this total daily one-way traffic at the end of the design period shall be checked against the 24 hours one-way traffic capacity, which is represented by big C here. Now, if the total daily traffic flow is less than the 24 hours traffic capacity, the ratio will have less than 1.0. That means the traffic capacity of the road that you have designed has not been exceeded throughout the design period, which is the best conditions that we're going to expect, as explained here. Now, if the traffic flow is greater than the traffic capacity, this will end up with the ratios more than 1.0. In this case, the daily capacity will be achieved during the design period. Now you will need to determine when it's going to happen. The Arahan technique provides the equations for you to determine the numbers of years that the traffic capacity will have been exceeded. We're going to discuss about this later. Now let us talk about the 24 hours one-way traffic capacity. You can get the equations from clause 3.3.13. It is taken as 10 times of small c. Small c represents the maximum hourly traffic volume, as given in clause 3.3.12. It is calculated using this formula: I multiply R multiply T, as given by the equation here. It is assumed that the C as acquired from this equation constitute about 10% of the 24 hours traffic capacity. Therefore, in order to compute 24 hours traffic capacity, you will need to multiply the C by 10 times. Now let us look into the components of the maximum hourly capacity, C. I represent the maximum hourly capacity under the ideal conditions. The capacity is governed by the road type. We have 2 lanes in both ways, 3 lanes both ways, and multi-lanes. And the passenger vehicle units per hours is given here. Taking the 2 lanes both ways, we are referring to 2,000 total for both ways. However, the calculation here is referring to one-way traffic flow. That means this numbers needs to be divided by 2 for the I value here. Now if the roads are made of multi-lanes, let's say 3 lanes or more in one directions, now the I here, it will be 2,000 passenger vehicles units times the numbers of lane. Next is the R. It represents the carriageway roadway reduction factors. This R factors is governed by the carriageway width as well as road shoulders width. The narrower the carriageway and the road shoulder, the efficiency of the traffic flow reduces. Therefore, the R factor here become very small. Based on the result given in the table here, you know that the most ideal situations is to have the carriageway more than 7.5 meter with the road shoulders of at least 2 meters, as this imposes no reductions in terms of the maximum capacity of the road in the context of the traffic flow. You may refer to this table here to compute the R. Next, we look at the T, which is the traffic reduction factor. These factors consider the effect of the terrain to the traffic flow capacity. They are flat, rolling, and mountainous. For flat terrain, you can consider it as a flat road. As for the rolling, that means the terrain is up and down, and mountainous, that means there are significant and continuous changes in terms of the elevations. If you look at the components of the traffic reduction factors, you can see it involves PC. PC represents the percentage of the commercial vehicles, as the commercial vehicles are normally heavier and their speeds are more significantly affected by the terrain conditions. What you see here, the maximum hourly capacity in one direction is calculated on basis of the hourly capacity under the ideal conditions. However, there are other considerations, such as the width of the carriageway as well as the road shoulders. Narrower road will have larger reduction, and this is going to reduce the hourly capacity of that particular road. Also, there is reduction factors due to the terrain, and this is governed by the percentage of the commercial vehicles. After determining the maximum hourly capacity, you know that this maximum hourly capacity represents 10% of 24 hours daily capacity. Your next step here is to determine the full capacity for a total of 24 hours in one way. Therefore, the C here will need to be multiplied by 10. Now that you acquire the 24 hours traffic capacity, check against the total one-way traffic flow at the end of the design period. If the capacity is greater, that means you will get a ratio less than 1.0, which is good. The road conditions is still okay throughout the design period. Now, if the capacity is lower, you will get the ratio of more than 1.0. You will know that the road capacity has been exceeded sometime during the design period. Now you will need to determine when the traffic capacity is exceeded, so that we can plan ahead, probably an extension or widening of the roads sometime before the traffic capacity is achieved. With that, you will need to determine the period required to reach the capacity, which is N here, as given by the formula here. C refers to the 24 hours one-way traffic capacity. Vx is referring to the total daily one-way traffic flow. As for R here, represent the annual growth. You can get the equations from clause 3.3.14. By looking at the equations, it seems like the log C is to be divided by the V, and then the whole thing is divided by the log 1 plus R. It is not clearly stated here. It could be a ratio of C divided by V are to be logged together, and then the whole thing is divided by log 1 plus R. Since there is no bracket here, at this moment I will interpret in the format of log C divided by V, and then the whole thing is divided by log 1 plus R. Now if you are using the equation here, I will recommend you to do some cross-checking first, whether the format of equations is correct. In fact, the Arahant technique provides a work example demonstrating how to use the equations given in the Arahant technique. Now, if you refer to the calculations here, the traffic capacity is calculated and the estimated daily traffic is also calculated. Now, when the estimated daily traffic is less than the traffic capacity, that means the capacity has not been reached after 10 years of the design period. The work example did not demonstrate how to use these equations. So if you really do use these equations, kindly be careful. Confirm the actual structures of the equation first before you use it.